Hi everyone, my name is Valery Markin and I'm one of the professors in this course. Today we will have the first session of Ask the Professor, and I'm very glad that we received many questions from you. Please keep sending the questions and keep posting us, and also please participate in the forums. It's quite interesting, and there are interesting discussions in this forum. So let's start with the questions. The first question was from Dot. He's asking about the type of track for high-speed line. In particular, his question is why in France they use ballast track, while in other countries like Germany, Japan and China they use slab track. Well, to answer this question is quite difficult to say why. It could be many reasons for that, and maybe not even technical reasons. Remember that in the decision-making process many stakeholders are involved, and some other factors different from technical ones could be dominating, although technical aspects are always taken into account. And in this course we will try not to explain why certain railway infrastructure manager makes certain decision and on the track choice, on the maintenance choice. On the contrary, we try to look on the fundamental principles of the railway systems and how it should work, and try to explain the logics and possible reasons behind the decision the infrastructure providers are making. In this case, in case of your question, we can simply look on the advantages and disadvantages of both systems. And if we look on the ballast track, you know that it's easy to build and relatively simple to maintain, because maintenance machines are very well developed for ballast track. On the other hand, you know that it also requires a lot of efforts related to the maintenance, especially to keeping the alignment of the track intact. Next question is from Yu Heng, and he's asking about the maximum thickness of ballast bed. And Roman made remark that in Switzerland, according to him, the maximum thickness of ballast bed is set to 70 centimeters. Well, what can I say about this? The thickness of ballast, the maximum thickness of ballast, depends on the quality and condition of the substructure, and therefore it's very difficult to give norm or standard for that. But using the knowledge in this course and the following three modules, you can give an answer to this question and come with a proposal to the to your own norm for that. What we see is that since one of the main maintenance methods for ballast bed is tamping, so when problems occur, most of the contractors, according to the instructions of the infrastructure managers, perform this type of maintenance. And in locations when settlement is observed, this maintenance wouldn't help at all, because then when the settlement is, for example, caused by deformation in the subgrade of or subsoil, then adding ballast during the tamping would even make the problem worse, you know. And therefore, for example, in transition zone, we often see that the thickness of ballast layer is increasing tremendously over there, and of course it does not help solving this problem. And the final question is from Lamro. He is asking how to deal with rail corrugation. In particular, is there any relationship between type of the track structure and rate of the rail corrugation? Well, yes, of course it is, and as it was mentioned in the course, the source of the corrugation, one of the source of corrugation is presumably the pin-pin natural frequency of the rails, which is caused by the discrete support of the rails. Well, how to well, keeping that in mind, we can come up with solution how to reduce the chance of corrugation. For example, well, we can use embedded rail structure. By using embedded rail structures, well, the rails are embedded in polyurethane mixture. The discrete support of the rail is eliminated, and now they're supported continuously. And based on the experience of one of the producer of the this elastomeric material in which the rails are embedded, Edilon Cedra, they say for that on embedded rail tracks less chance of corrugation was observed. But again, the embedded rail structure on the main line is not used very often because it's quite expensive type of structures. But again, that could help. And also other sources, if you look on the other sources of the corrugation, it could be also vibration of the structure itself. I think in one of the additional literature in this course, you can there is a paper on the reduction of the corrugation in Beijing metro, and that which was caused due to by the natural frequency of the structure, which were coincided with the natural frequency of a wheel set. Apparently they changed this type of the structure and didn't look on the type of the vehicle running on it. That also can cause rail corrugation. So in this case, well, the one of the measures could be to adjust properties of the track, for example. Well, what I want to say is that you have to look on the sources of the problem, and then you can propose the proper measure. And the second part of his question was what is the best periodic time to do preventive grinding to eliminate this rail corrugation? Well, again, the best periodic time, well, it's difficult to say because if you do it's too often the maintenance when you just grind unnecessarily the material. If you do it not often enough, not timely, then you can well, the damage can be developed to the very serious dimensions. So in this case, I must say, well, it depends on the operating regime. And the other suggestion which I could make, well, stay in follow our courses, and after the module C, you can come up yourself with the best answer to these questions. Well, that was all for this week. Again, I would like to thank you for all the questions you've sent. Please continue sending the questions. Please continue participating in the forums, participating in this course, and see you next time. Bye.